Good day, students. In this clip, we're going to go over how to factor difference of squares and also perfect square trinomials. So let's go ahead and write down the title of this lesson. Um, factoring difference of squares. Notice difference, okay? Not sum. Difference of squares and perfect square trinomials. Perfect square trinomials. Okay, so let's go ahead and take a look at the following examples. We're going to start out with difference of squares, and then we're going to extend it from there. All right. So the instructions is as follows: factor the following expressions. Factor the following expressions. Number one, what if we had the expression a squared minus b squared? Now, first thing you want to do when factoring any expression is you have to break it down to make sure there are no common factors to be extracted first. So let's go ahead and break this down. If we break down a squared, we'll have a times a. And then we decompose or break down b squared, we have b times b. Now, if you look at these two terms, there is nothing in common. So we multiply them back together, a squared minus b squared. Now, since it's a difference of squares, since you have a minus, this is a square, and this is a square, we can apply the factoring trick. Namely, we just root the first term and root the last term, and then you plus and minus the square root. Okay? So what is the square root of a squared? Square root and square opposite, so they cancel out. So we're going to have a plus the square root of b squared. The square and the square root cancel out. A plus b, that's the plus. We also have to do the minus. A minus b. There goes the factored form of the expression a squared minus b squared. Okay? Alright, let's move on to question number 2. What if we had the expression a squared plus b squared? So the first thing we do is we break it down to see if there are any common factors that can be extracted. So if we break down a squared, we have a times a plus, break down b, we have b times b. Are there any common factors? No. So we multiply them back together, a squared plus b squared. Now we're going to apply the difference of squares formula here. Now this is a square and this is a square. This is a sum. Note, if you have sum of squares, you cannot apply the difference of squares formula. Alright? This is a prime expression right here. So guess what? It cannot be factored any further. So our final answer is just simply a squared plus b squared. Alright? It cannot be factored any further. Alright, let's try another example. Example number 3. What if we had the expression a squared plus 2ab plus b squared? Now this is a formulation for the perfect square trinomial. So to factor this is a trick we apply here. If you have a perfect square trinomial, you take the square root of the first term and take the square root of the last term, and then you bring down the middle sign. Alright? So if I apply that here, the square root of a squared is a. Bring down the first sign in the middle, plus square root of b squared is b, and then the whole thing quantity squared. Okay? Alright, so there you have it. That's the factored form. That's our answer. Alright, let's move on to question number 4. What if we were supposed to factor the expression 3x squared minus 27? So what we do here first, we break down everything to see if we can take out a common factor. So we have 3 times x minus, if I break down 27, I can use my factor tree. Take out 3 and 9, 3, and then 3. So it's 3 times 3 times 3. So what can I factor out of here? I notice that 3 is common, so I can pull out the 3. Alright, so that's why it's good to always break it down so you can know how to take out whatever is common. So I take out a 3, and x times x is x squared, and then 3 times 3 is 9. Okay? Now let's go ahead and factor this expression right here. This is a difference of squares, a square, a difference symbol, and then another square. So what I'll do is I'll root the first and the last, root the x squared root 9, and I'll add and subtract the square roots, okay? So this 3 that has been factored out, you just simply bring it down. Square root of x squared is x, because x squared and x cancel out. Square root of 9 is 3, so you're going to add them, plus, and then you're going to minus them. Square root of x squared is x, and then minus 3. Alright? So you add and subtract the square root of these two terms. Alright, so there goes your factored form for that expression. Alright, let's go ahead and try another example. Example number 5. What if we have, well, actually, I think I just did 5. No, this is 4. Alright, example 5. What if we had the expression a squared minus 2ab plus b squared. Okay? In example 3, I neglected to break it down, but it's always good to break it down first to see. Alright, so let's break this down and see if we can factor out anything, and then we're going to try and factor the whole perfect square trinomial. Okay? So if I break this down, I have a times a minus 2 times a times b plus b times b. Alright? So nothing comes out. I'll multiply back together. I have a squared minus 2ab plus b squared. Alright? This is a perfect square trinomial. So to factor this, all you do is you root the first and the last, and then you bring down the middle sign. Alright? So if I do that, the square root of a squared, the square root and the square cancel. You have a, bring down the minus, and then square root of b squared is b, quantity square, and there goes the factored form. Okay, so let's box this. Alright, there you have it. Okay, let's move on to question 6. So for question 6, let me do it over here. We have y squared plus 49. So let's break this down. Well, if we factor out y squared is y times y. If I break down 49, it's 7 times 7. Anything common? No. So we multiply it back together, y squared plus 49 into the original form. Now, can we apply the difference of squares formula here? This is a square, this is a square, but this is a sum of squares. So you can't factor a sum of squares, so this is technically prime. So there goes our final answer right there. Alright, let's try another example, question number 7. Question 7, we have the question x squared plus x. So how do we factor this? First thing we do is we break everything down. If you break down x squared, you're going to have x times x using your factor tree. And then this one has nothing to be broken down with. So I can just take out a 1 out of it. 1 times x, okay? Alright, so what can I factor here? You notice that x is common. So I can pull out an x and an x. If I factor it out, I'll have x on the outside, and I'll be left with x plus, since this x is gone, x times x plus 1. And there goes the factored form. Now, is this a square? This is not a square. This is neither a square. This is a first degree polynomial, so it cannot be factored. So it's prime, the inner one, so that's our final answer right there. Alright, let's try another example, question number 8. Now, what if we had the question 9, y squared minus 49. So what we do first is we break down both terms and see if anything can be factored out, and then we advance from there. So when we break down 9, you have 3 times y minus, if you break down 49, it's simply 7 times 7. Now, what can we factor out from here? Nothing is factorable. There are no common factors on both terms, so we multiply it back together, 9y squared minus 49. Okay? Now, how do we factor this? To factor this, This is a square, this is a square, and this is a minus. So this is a difference of squares. So what we do here is just root the first and the last, and then you add and subtract the square root. Okay? So what is the square root of 9y squared? It's 3y plus the square root of 49 is 7. This is the plus part. Remember, you do plus and minus, okay? To do the minus, you take the square root of 9y squared, which is 3y, minus the square root of 49, which is 7. And there goes your factored form. Alright, let's fix that. Alright, let's go ahead and try another example. Let's take a look at question number 9. What if we were asked to factor this perfect square trinomial, 49x squared minus 14x plus 4. First thing we're going to do is we're going to break it down and see if there are any common factors we can extract. If there aren't any, we put it back together and then we'll factor, okay? Alright, so let's break this down. 49 is 7 times x minus, if we break down 14, 14 is 7 times 2 times x. You can break this down using a factor tree. And if I break down 4, it's just 2 times 2. Okay? Now let's look at all these three terms. Are there any common factors? Anything common in all three? This has a 7, this has a 7, this doesn't. This has 2, this has 2, this doesn't. This has x and x, this doesn't. So there's nothing that's common, alright? So we're going to multiply back together. 49x squared minus 14x plus 4. Alright, so let's factor this. Using the perfect square trinomial trick, you take the square root of the first term and the last term, and then you bring down the middle sign, okay? So this factored form of this will be 7x, because the square root of 49 is 7, and the square root of x squared is x, minus the square root of 4 is 2, the whole thing quantity squared. Alright, so there goes the factored form of a perfect square trinomial. Alright? Okay, let's try one more example, and that'll be that. Question number 10. What if we had the expression 18x squared plus 24x plus 8. Alright, so first thing you want to do is break everything down and see if there are any common factors that can be extracted and then go on from there. So let's start out with 18x squared. Let's break this down. You're going to have 2 times 9. And then break down 9. 9 is just 3 times 3. Alright, so, and then you can put the x and then the x there for the x squared. So for 18x squared, it's going to be 2 times 3 times 3 times x plus. Alright, let's break down 24x. To break down 24x, we can take out a 2. 2 goes into 24 how many times? 12x. Take out another 2, and then we have 6x. Alright, and then now let's break down the 6x. To break down the 6x, we'll take out 2 times 3, and then times x. So basically it's 2 times 2 times 2 times 3 times x. So for the 24, we're going to have 2 times 2 times 2 times 3 times x plus. And then if we break down 8, we can take out 2 from 8, that's 4. Take out another 2, that's 2. That's 2 times 2 times 2. So 2 times 2 times 2 for 8. Now let's examine all three terms and see what's common that we can factor out. Oh wait, there's a 2 that's common in all of them, right? So I have 1, 2 here, 1, 2 here, and then 1, 2 there. So I can extract that 2 from the whole thing, factor it out. If I have 2 factored out, all these 2's are gone, so I'll multiply what's left. 3 times x is 9x squared. And 2 times 2 times 3 times x is 12x. And then plus 2 times 2, which is 4. Okay? Alright, now this is a perfect square trinomial in here. To factor that, we're going to use the trick I thought we went over earlier. So to do that, all you do is you root the first term, and you root the last term, and then you bring down the middle sign. Okay? So this 2 that's out here, just bring it down. Don't forget it. The square root of 9x squared is 3x plus the square root of 4 is 2, quantity square. There goes your factored form. Okay? And that's it. So thanks so much for paying attention to this presentation. And you can feel free to subscribe to my channels and share this video with your friends if you liked it. And also you can post requests for math help on the comment spot under this video. Collection of clips can be found on Math Good Served. Thanks again and have a wonderful day.